In B6, so B, so write a B there, so I know. We're going to go to the directions, apply a couple pages forward. In B, it says, model each scenario using a table, graph, and equation. So I have to do three things. Table, which looks like that. A graph, looks like this. And an equation, which you write with your graphic organizer. So let's go to B6. Here is our table. Let's get an equation. The square of x. So you can draw yourself a visual. A square. And it's basically saying that x is on the outside. That's what it's implying. Because, class, if you wanted to find the area, what's x times x? X squared. Does that make sense? This represents x squared plus 5. So that is our equation. X squared plus 5. Okay, now it just tells us to make up some numbers. I would always use 0. You can do negative numbers if you want. The output, this is what the fancy function notation looks like. You can make that a y if you wanted to, because remember, f of x and y are the same thing. So if I put in 0, class, what's 0 squared? And 0 plus 5? 5. If I put in 1, class, what's 1 squared? And 1 plus 5? 6. But if I put in x equals 2, 2 squared? 4, and then 4 plus 5 is 9. If I put in a 3 here, 3 squared, 9, 9 plus 5, 13. And then 4 you put in there, 16, 16 plus 5 is 21. Okay, we have a problem. You'll see it when you graph it. This is what happens when you pick numbers that, yeah, you'll see it. 0, 5. 1, 6. Pay attention. There's 2 boxes on the x values for the whole value 1. So 1, 6. 2, 9. So here, each box is counted as 1, right? 1, 2, 3, 4. And then I have 3, 14. And then 4, 21, which is off of ours. So here's my problem. If I sketch and curve this, class, is this exponential? Yes or no? How do you know this is not exponential? Because what's the exponent? It's a power of 2. It's a square. It's quadratics. You might be asking, where's the other part of the quadratics? What we would have to have done is pick some negative numbers. Negative 1. Negative 2. Class, what's negative 1 times negative 1? Positive 1, and positive 1 plus 5? 6. Negative 2. What's negative 2 times negative 2? Positive 4, and 4 plus 5? 9. And then you recognize, if you see it right here, sorry, at 5, the numbers are becoming symmetrical. Does that make sense? What's the next number going to be? 14. So if you graph that, negative 1, 6, left, they're going to be symmetrical of the same points on the other side. What does that mean? Look. Guys, look, look. Quadratics are symmetrical. So the same points on the right side are actually on the left side. So right here, I'll do the next one. Watch this one. Right 2, up, let's see, that's 5 to 9. Up 4. Left, 4 boxes, and then up 4 boxes. And that's already the order pair, negative 2, 9. Does that make sense? We'll learn later on this year, too, that you'll notice that in the quadratics, the transformation here is plus 5. You'll recognize that there's no parentheses, so it's being shifted up 5 units from the origin. Okay, so let's double check. We've got an equation, we've got a table, and now we have a graph. So we've done all 4 parts there. What was hard about this one? It was just translating the words into variables.